Hello, it's Stat 134, Lecture 27. Last time we did Section 4.5, Expectation of a Non-Negative Random Variable using CDF, and we saw that the expectation can be written as the integral from 0 to infinity of 1 minus the CDF. And so an example of that is, say that x is geometric 1/2. So that means that the probability of x being 1 is a half, x being 2 is a quarter, x being 3 is an eighth, and so on. So then you can see that the CDF is 0 for x less than 1, 1/2 between 1 and 2, 3/4 between 2 and 3, and so on. And so I've pictured here the CDF, and the area between 1 and the curve is the expectation of x, and that is the sum of 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, and so on. That's a geometric sum. So it's 1 over 1 minus 1/2, which is 1 over 1/2. 1/2 is p. So that is the familiar formula for the expectation of a geometric. And notice that this is exactly the tail sum formula. So using the CDF to find the expectation is sort of a generalization of the tail sum formula that we've seen before. Today we're going to look at student explanations for the MGF concept test from before. As well, we're going to talk about Section 4.6 order statistics and Section 5.1 continuous joint distributions. So last time we had the MGF concept test, where you were given a density is x e to the minus x for x greater than 0, and asked what the MGF is. And most of you gave the right answer, but for a variety of reasons. One person said that they recognized that we have a gamma here, that this is the density of a gamma. R is 2, lambda is 1, and we know the MGF of gamma. So that led the person to understand that the MGF was 1 over 1 minus t quantity squared for t less than 1. Another person used integration by parts, or the substitution method was another way to do it. One person did something fancy and recognized the MGF as 1 over 1 minus t times the expectation of an exponential 1 minus t, which is 1 over 1 minus t times 1 over 1 minus t, which is the right answer. So very creative. The second MGF problem gave you the MGF and asked you to figure out what the distribution is. So remember that the MGF uniquely determines the distribution. So in this case, you recognize that R is 1/2 and lambda is 1. So this is a gamma. Then we did the order statistics of uniform 0, 1. So imagine throwing 5 darts at the unit interval from 0 to 1. So the order statistics are is the position of the darts in increasing order. So UK parenthesis is called the kth order statistic. It's the kth largest value of U1 to UN, assuming no ties. The probability of a tie is 0. So U parenthesis 1 is the minimum, and U parenthesis n is the maximum. I want you to remember that if you have 3 red, 2 green, and 5 blue marbles, the number of orderings of these 10 marbles is 10 choose 3, 2, 5, which you can also write as 10 choose 3 times 7 choose 2 times 5 choose 5. And we're going to use that below. So now we're going to find the density of the ordered k statistic. and by writing the probability that that the kth order statistic is in dx as the density times dx. And so for the kth order statistic to be in dx, it means that there are k minus 1 darts before x, 1 dart in dx, and n minus k darts after x. So we can write that out as the probability shown here. Use the multiplication rule, and we see that we get n choose k minus 1, 1, n minus k times x to the k minus 1, 1 minus x to the n minus k plus 1 minus 1. Now the reason I write 1 minus x to the n minus k plus 1 minus 1 instead of just 1 minus x to the n minus k is because the order statistic is going to be a special case of what's called the beta distribution that we'll see next time, and I'm just setting things up to make that comparison. So then I asked you guys to write out, not using the formula here, but just from scratch, to figure out what's the density of the min and max. So for the min, that means that the first dart is in dx and n minus 1 darts are between x and 1. And so that density is n choose 1 n minus 1 dx 1 minus x to the n minus 1. So the density actually is n 1 minus x to the n minus 1. And for the max, it's similar. It's n times x to the n minus 1. So here's a picture. What you have is you have a one parameter family of distributions on the interval 0 to 1, starting from the min going to the max. And then I asked you, say that you have x squared 1 minus x to the 4th is the variable part of a random variable. How many darts do you throw? So you can realize that x squared means that there are 2 darts between 0 and x. 1 minus x to the 4 means there's 4 darts between 1x and 1, and then there has to be 1 dart in dx. So we're throwing 7 darts down. So this is the density of so x here is the third order statistic, and the density is 7 choose 2 1 4 x squared 1 minus x to the 4th. And you can further extend the idea here by, you don't need order statistics for the uniform. You can look at order statistics for, say, the standard normal. So the standard normal, so what we're going to do is we're going to throw 10 darts at the line here from minus infinity to infinity. So this is not between 0 and 1, this is on the entire real line. So imagine throwing 10 darts. To find z, the 4th order statistic, that means that I have three darts before z, 1 dart in dz, 6 darts between z and infinity. So you can write out what this is in terms of the CDF and the density function. So here the CDF is capital phi, the density is small phi. So the chance of being in having 1 dart in dz is phi z dz. And really, when I say dart, I should just say standard normal, because it's not really, it's not a dart in this case. Great. So then we started talking about the continuous joint distribution. So say this is really a generalization of in the discrete case. We have x and y joint density. F of xy means that f of xy is a non-negative function. You can think of it as surface over the plane, and the integral of this surface is 1, so that volume over the plane has to be 1. If a is a subset of the plane, then the probability that you're in A is the integral of the surface over A. and the probability that x is in some dx, y's, and dy is the volume of the surface over this little rectangle dx dy. So here's a picture of that. So to tie everything together with what we've done today, say you throw down 5 darts on 0, 1, find the joint density of x is the second ordered statistic and y is the fourth order statistic. So here x comes before y because x is the second order statistic and y is the fourth order. So I have x and y in my unit interval here. It means I have to throw 1 dart before x, 1 dart in dx, 1 dart between x and y, 1 dart in dy, and 1 dart between y and 1. And so my density is then 5, choose 1, 1, 1, 1, 1, x, y minus x, 1 minus y, and that's it. And for x less than y, between 0 and 1. Fantastic. Have a great day, guys, and I'll see you next time.